algebra students. Today we're going to be graphing absolute value in equations. Excuse me. All right, now these are actually super duper simple. They're almost easier than graphing like slope-intercept form. Almost easy or than that, but you had to know that how to do that first before you do this. I'll tell you what, just to start, I'm going to make a little t-table here. And I don't want you doing t-tables on homework, but I'm doing a t-table so you can see how the picture is going to go. And I'm going to plug in 5 points, 2, 1, 0, -1, and -2. And then, of course, to get my answers out, I've got to plug them into this equation, y equals the absolute value of x. All right, so I'm going to put 2 in for x, and the absolute value of 2 is 2. Put 1 in for x, the absolute value of 1 is 1. Put 0 in for x, of course I get out 0. If I put -1 in, -1, take the absolute value of it, +1, right? Put in -2, I get +2 out. So my points for this graph are going to look like this. And you can see I'm going to get a V shape. For an absolute value, you will always, always, always get a V shape. Now, the V might be skinnier or wider, or it could even be turned upside down in some cases. In fact, think about that. I want you to see if you can tell me later on, like on Monday, when the V would be flipped upside down. I bet a lot of you could figure it out just by watching the examples. Okay, so that's how simple it is. Now, one thing I do want to point out to you here, that this point here, the bottom of the V, that's called the vertex. Yeah, that's the vertex of the graph, okay? If you can find the vertex and quote unquote find the slope, then these are going to be super duper simple problems. By the way, it looks like the slope on the right half is rise 1, run 1, rise 1, run 1. But the slope on the left half is rise 1, back 1, rise 1, back 1, plus 1, minus 1. And that's going to be the case in absolute value equations when you graph them. Now, if this were y equals mx plus b, slope-intercept form, you would find the slope right here in front of the x. Well, in this case, our slope is going to be here. And since there's no number there, we assume it to be a 1. And notice I said the rise was run and the run was 1. Okay, on the right half. On the other half, the left half of the vertex, you get a negative version of the slope. Okay, and that will always be the case. The y-intercept is here, the number added or subtracted to x. Well, we don't have anything added, so it's like +0. And notice my y-intercept is at the origin. Okay, so let's keep those things in mind as we go on. Let's look at this one here. I'm still going to do a t-table, only because I don't know if you can see the shortcut yet, and I'm hoping you'll see it real soon, because t-tables are good, but they're so inefficient when you can understand what's truly going on. And this time, I'm going to plug in some different points. I'm going to plug in, say, -6, -4, -2, 0, 2, 4, and 6. Yeah, I know that's a lot of points. But again, remember, you're not going to be doing a t-table. All right, I'm going to start at the bottom. I'm going to put 6 and 2. I'm going to get 8. And so 1, 2, 3, 4, 5, 6. 8 should be right about there. And then I'm going to infinitely clone him. I feel so powerful when I infinitely clone things. All right. We're going to have the point 4 and then 6, right? So I need the point 4, 6. I think it's going to be right there. And then I'm going to get the point 2, 4. And so 2, 4 should, oh, sorry about that. 2, 4 should be about there. Okay, and I notice a lot of you are probably going, well, Mr. Lawrence, can't I just use the slope from here? You can, but I'm trying to get you to understand something, so just go ahead and bear with me. 0, 2 will be on the graph. I'm just plugging the x values into the equation. 0, 2 would be right there. Okay, now at, let me see, at -2, I'm going to get 0, aren't I? So at -2, 0, that looks about right. And then at -4, I'm going to put -4 in, get -2. Absolute value of -2 is +2. And so that one at -4, I'm going to go up to +2. Looks like it's changed direction, doesn't it? Put -6 in, I'll get -4. Absolute value of -4 is +4. And then I will get 5, 6, 1, 2, 3, 4 should be right about there. And so therefore my graph is going to look like this. Okay. Um, so what do we say about this? Well, here's our vertex down here, right? There's our vertex. What are the coordinates of the vertex? Looks like they're -2, 0, right? On the last problem, the coordinates of the vertex were 0, 0. That's interesting. -2, 0. Okay. Looks like nothing's being added to my equation. It's got like a +0 there. Um, my okay. Um, that's fine. My slope appears to be 1, I believe. Let's see, am I rising 1, running 1, rising 1, running 1, rising 1, running 1? And of course, on the left-hand side, I rise 1, back 1. I get the -1 for a slope. Okay. Huh. You know, I'm thinking that if we could find the vertex before we started graphing, we could just use our slope and then go from there. Let, let's see how that works on one like this. One more time, I'm going to make a t-table. All right. And this time I'm going to put in -3, -1, 0, 1, and 3. Okay. I put -3 in. I believe I'm going to get 5 out. I put -1 in. I'm going to get 3 out. 0 in is going to get me 2. 1 is going to get me 3, and 3 is going to get me 5. All right. Let me infinitely clone him so I can feel powerful. There we go. And so I'm going to get -3, 1, 2, 3, 4, 5. All right, -1, 1, 2, 3. 0, 2, 1, 3, and 3, 5. And there we go. I get a perfect graph of symmetry. And when I go to graph it, there we go. Okay, so there is my graph. Now, let's find the vertex. The coordinates of the vertex happen at 0, 2. Huh. 0, 2. The last one happened at -2, 0. That's very interesting. Looks like my slope is on the right-hand side, +1 over 1. On the left-hand side, -1 over, well, +1 over -1. So I rise 1, run 1, rise 1, run 1, rise 1, run 1. And up here, I rise 1, go back 1, rise 1, go back 1, rise 1, go back 1. All right. Well, let's take a look at example 4. If I can find my vertex right off the bat, this becomes a super duper easy thing to graph. I got a feeling I know my vertex. I'll bet a lot of you can guess the y-coordinate of the vertex right off the top of your head. See, on this equation, number 3, the y-coordinate was 2. On the second equation, the y-coordinate was 0. What do you think the y-coordinate is going to be on this fourth equation here? Yeah, that's right, Vinny. It's -4. Very good. Nice job. All right, now for this one, I'm going to call on Nelson. Nelson, what do you think the x-coordinate is? Well, you know what, Nelson? I'm not sure exactly what you said, but I thought I heard you say -3. And I'll tell you, I don't agree with that, buddy. Let's take a look at this one here. Let's see, 0. No, let's look at this one. When it was x plus 2 inside the quantity, my vertex was -2. When it was x plus 2 inside the quantity, my vertex was -2. All right. So if it's x minus 3 inside the quantity, my vertex is going to be, my x-coordinate is going to be positive 3. All right, so I'm going to plot my vertex, 3, negative 4. 1, 2, 3, 1, 2, 3, 4. Right? Okay. Now that I've plotted my vertex, I can use my slope. And in this case, it's just the same. It's 1 over 1. So I rise 1, run 1, rise 1, run 1, like that. And then I, of course, have to rise 1, go back 1, and rise 1, go back 1. All right. And there we go. It's as simple as that. So to find the vertex, like, let's just do a quick one here. I got another minute. Hold on. Look at these 3 examples here. We'll call them A, B, and C. A, B, and C. Do you think you could tell me the vertex of each equation? Well, I'll do this first one here. Negative 5, 2. I plot that point, and then I use my slope, which in this case is 1 over 1 to the right, and then to the left will be negative 1 or 1 over negative 1. All right, on B, my vertex, hopefully you can tell me, should be 6, 3. And then on C, my vertex should be 4, negative 6. So in other words, the x-coordinate of the vertex makes the absolute value 0. Yeah, if I put negative 5 in for x, I get negative 5 plus 5. I get 0 inside the absolute value. If I put 6 in here, I get 0 inside the absolute value. If I put 4 in here, I get 0 inside the absolute value. The y-coordinate is easier. It's just the number that's added or subtracted to the absolute value. Okay? So, with an absolute value graph, you'll always get this distinctive V shape. Sometimes, which I haven't told you when, it'll open upside down. I want you to be able to tell me that on Monday. And sometimes you can get a real wide one and a real skinny one. I haven't told you those either, but we're going to see if you can figure that on your own. It should be pretty simple. Okay, Mr. Lawrence signing off. Good night, everybody.